Alright, another draft physics video production. Humble pie or something, maybe? Yeah. Not giving up on the theory, but I thought of two obvious problems. Well, not just problems. One of them was that nobody mentioned. Hydrogen atoms probably can't have momentum. Now, I don't know for sure. That's why the channel is called Draft Physics, because I don't know everything. But as previously argued in previous conversations about mechanisms for velocity, it sort of was my conclusion anyway, that you had to have at least a helium nucleus before you could maintain momentum. So electrons, protons, hydrogen atoms, neutrons, protons, and neutrons, don't have enough structure to maintain velocity. That's why we can't really make a gun of those things and kill people. Practically. You have to have an anode and a cathode, all that kind of stuff. You have to keep pushing the bullets. If you don't keep pushing them, they don't keep moving. And so that would be a problem for the overall theory, in the sense that there's much more hydrogen in empty space than there is the other elements. Now, there's still a lot of the other elements. Even, gold atoms, all kinds of atoms are flying through space, so it's not like it's dead, but obviously gold isn't transparent. But oxygen is, and oxygen's a big atom, and probably can maintain a lot of velocity. Anyway, so that's one problem. Second problem is, yes, I started drawing it different ways to say, okay, I've got to be able to explain this. It's so simple. I mean, it's obviously more distance. I'm still arguing it's obviously more distance. But I said things like it doesn't matter when, and no, that was stupid. It's always going to matter when. They're independent events, but the timing of the cycle is critically important to how they land. So I thought of the simple redshift. So let me just do the redshift first, and then we'll see if anybody commented. I haven't looked at the comments yet, because I have to concede this is worth arguing. And I've been arguing that the argument should be over by now, but there's an argument to be made. But I'm going to make the simple redshift argument, and then just explain that we just have to figure out why this isn't happening, kind of a thing. So I'll be back in a moment. Probably. Okay. Alright, should be back. Alright, so in traditional redshift, personally, this is how I sort of make it understandable, in terms of there's some mechanism in whatever the device is, and you could illustrate it as something that just drops things at a certain rate. Okay, and they have a certain distance between each other, so they're falling down. And the object they're on is moving in this direction, let's say. Shouldn't make the arrow where they're going to drop. So, and the idea is this is just going to drop them, this device that's, connected on this platform that's moving this way, is just going to drop things, and as it drops them, the frequency is going to be increased, because it will drop one here, and then it's going to move as this next one drops, and so it's going to add this distance, the drop rate, plus this distance, the move rate, and that's going to end up being the distance that the objects have that are going this way. Let's just pretend when they hit, they move. And so that's going to be, their frequency is going to be adding this distance to the moving distance, how far they moved in that much time. So whatever speed you're going here will decide what speed they're dropping is also going to decide. So the rate of gravity is deciding. But the point is you can just make any device, any spinning wheel, okay, that just drops things. So it spins and it drops a thing. Once a spin, it drops it. And it's going to add the time it would move in this one turn. Okay, that's how far it would move in one turn. Yeah, so plus the distance it moved in one turn. So the two things would end up adding and creating the longer frequency. Oh, I don't know if that was a very good illustration, but anyway, point is, yeah, so now I got the arrows going two ways. I mean, that was a real mistake there. Okay, never mind. All right. Probably should really script the next video to make sure I don't make any mistakes. But the point is, there's a time thing that this frequency is going to be added, because it'll drop a thing and then it's not going to, see how to say it. Yeah, how to say it. So I was thinking of photons, because photons automatically move. But I was thinking like a paint machine or something that's going to put a stripe on the ground. It's the rate of the machine. Whatever rate you're moving it at is going to amplify whatever rate it's dropping it at. So the two will add up. So the drop rate will become one part of the new wavelength, and the distance moved in the time you were dropping it will become the other part of the wavelength, and the two of them will add up to a larger wavelength. So the faster you're moving away, the more distance between these versus these in space. So again, the idea would be is having them go down, having them moving into the system this way rather than moving into a system this way. So if you're moving into them this way, that's where it matters. You're going to end up blue shifting, as the one guy argued. You're going to end up blue shifting by the time you get here and here. So you're going to shrink this frequency a lot if it's coming in this way. If it's coming in this way, top to bottom, you're not going to blue shift it at all. So that's the difference. Is that if this is on the same line as your motion, this frequency, then the device doesn't work anymore. So if you're collecting spots on the road and then re-putting them on the road, the device breaks in terms of making the wavelength larger. So that part of the argument I'll concede. If this this energy will undo the shift created by the motion. But if it comes down this way, it won't undo it. All right. So the direction matters. So what do we take from that? So I'm saying that this obviously needs more work, because in fact in my example it is moving towards the photon, so that's going to be a problem. But the sort of the backward solution is the hydrogen atoms are also moving this way and this way, and so maybe that fixes it. It's ironically. In terms of, it doesn't matter which one ends up going perpendicular, as long as you have something perpendicular to the motion, then the shift is possible. All right. So then there's nothing moving this way to create a bigger wavelength. Maybe, I don't know. I have to think about it. All right. So the other argument that's important, I had it a second ago. All right, well, I'll pause and then I can think about it. As I know it's another argument. So I wish this would do this more reliably. Okay, so besides saying that saying that they're isolated events when they can't be isolated events because they are events in sequence, and it's an interpretation of an event in sequence. You can't separate the letters from the word kind of argument. Okay, besides that being wrong, I forgot it again. The other issue is speed. Speed does matter, and I was trying to say, well, let's ignore speed because it just gets in the way. But the fact is that the atom, whatever it's going to be, helium or hydrogen, is going to be moving a lot slower than the light, the photons. So whatever frequency the photons do have is like 10,000 times greater speed. So this wavelength becomes, very, very small relative to the atom because it's moving really slow. Yeah, that's how that would work. So time scales are very different for the two objects. So in a sense, you could argue that all three of them could be dropped into a trap at the same time, theoretically, by some mechanism, and then dealt with. This distance between them could then be a drop rate and all that kind of crap. But I mean, I haven't figured out any sensible mechanism for that or anything. I haven't really thought about it. But it's just the point is that this clump of energy is a small amount of distance compared to the speed of this hydrogen atom. They're going really fast, and this is going really slow, relatively. And that probably makes a difference. Maybe. I don't know. That's right. I'm just saying, there's an argument to be made here, so I have to do some more thinking, unfortunately. I have to spend more time on it. So again, but the other complexity is what I'm saying, hydrogen atom. Well, it's really not a hydrogen atom, right? It's a moving electron. The thing that's going to happen is the electron is going to move from one location to another location. That's the delay. That's what causes light to slow down, is the light hits the electron, gives it momentum. The electron's momentum is then stopped, okay, by an equal but opposite force in this mechanism of proton versus electron. And the electron, through the process, the electron itself doesn't necessarily do it, the system then readmits the photon. So it's going the speed of light here, and it's going the speed of light here, okay, speed of force, I should say, right? But here, it's going much slower, slower speed. How much slower? It could be a lot slower, and that's that's why photons seem to slow down when they go through a transparent material. Is likely, not only are they not traveling a perfectly straight line probably through the electrons, but they're traveling at the speed of electrons for part of the trip. So inside of a material you'd have more than one of these atoms, and these atoms would be doing the same thing over and over. Now the interesting thought is in a transparent material, when this is happening, when light's transmitting through it, so this is at the speed of light, this is, I just want to make sure, this slows it down, then it's going back to its regular speed, then slow down, because it's going to move as an electron. The force will be as an electron here, and it's much slower. So that would basically tell you that the distance between atoms is maybe proportional to the distance across the atom, because the 40% sort of indicates a 50-50 almost. So that's another. So there, you could almost argue that this distance between the atoms, on average, is 40% of this diameter, right? Well, I'm just trying to think of whether that works out. Whether you have to make it 20% to double it to make it 40, but anyway, it doesn't matter. Okay, that's another problem, is nodes. When you're doing wavelength, you have to think about the nodes, but the first object, that's what makes it so obvious to me that it has to work, is that you're obviously, when you do the going backward thing, you're obviously creating more distance, and you'll obviously, from the target's perspective, the stuff will arrive slower when it's moving. So if it's the atom's moving and stuff is going in, it'll certainly arrive at the next point later, sort of just as this almost describes. It can't get there as fast as it moved backwards before it moved forward again. So there's no denying that the first photon, in a sense, has an increase in its wavelength because it gets to the target later. you know, so it's an obvious delay, and the only argument is the delay in each wavelength, and I'd argue it would have to be because it's happening to each photon. But anyway, I mean each element of the photon. So yeah, so there's this adds more to the subject in the sense you really have to think about motion of electrons relative to the motion of the atom, and overall. So you have to give the electrons momentum in one direction, and then you're knocking them in the opposite direction. And then when you do that, you sort of understand there's an equivalency because electrons are either going this way. So that's another part of a physical interpretation of what the starting point are, the starting axioms. By the Bohr model, well, you couldn't see that. That's strange. Yeah, I can see it. By the Bohr model, so you have the nucleus, and the electrons are going around these orbits, and then when two atoms are connected to each other, the electrons are supposed to be doing some kind of this thing around both of them. And I would argue that what they could be doing, just because, what the hell, you can't call me when I'm working. I don't really do anybody, sooner or later I'll get comfortable enough to talk to human beings again, but I just haven't had the ability to do that yet for whatever reason. There's a lot of distractions and complications, and anyway, so there's a lot of people who've contacted me I just haven't responded to, and I'm sorry about that. It's just life is difficult. Alright, so where was I? Where was I? Alright, so what I'm arguing is that electrons are just vibrating in this location. That's all they're doing. They're not really going all of these places. They're just vibrating here, going all directions all the time, changing, because the forces, the tensions are all equalizing. And so the basic point I've made before is that if you have 5 engine pieces inside of you, an odd number, and these little engine pieces, depending on which way they're going, right, whichever momentum they have, and it'll always be opposite each other, you sort of get the idea that it can only be in a state where it has 3 to 2, or 4 to 1, or 4 to 1, and 3 to 2, that kind of thing. You can only have, it can only be going one way or the other way. So essentially, an electron, if you stop it from going towards you with enough energy, it'll obviously be going the opposite way. I mean, it can't go neutral. It can only go, it's either going left or right, it's either going up or down. So at any one moment in all 3 dimensions, it's going one way or the other. And that's why you have Brownian motion, that's why you have all of this, the idea of vacuum energy. Is because there's no vacuum state for an electron. It can't ever be not having a bias in one direction or the other, just because it's manufactured odd in how it stores energy. So there can't ever be a 2 and 2 or 3 and 3. There can only be these odd numbers. Alright, so that's probably enough on that. Alright, so now we'll go back to comments, I guess. So anyway, I haven't given up. I'm just saying this is obviously more complicated than I wanted it to be. The principle of redshift, like I said, I'm just saying the idea that redshift is just has to do with the fact that you're adding negative distance, which, if any timed sequence that's happening, will automatically extend that sequence. And if you're going the opposite way, you're going towards the target, and you're making essentially less distance. I think how to say that right. Well, yeah, I'll wait till I'm doing it professionally, because I've already made enough errors on this subject. Okay, so you didn't see me erase, just proving I can do it. Alright, so off to the comments, and we'll see if there's anything there. God, I'm really tired. Yeah, anyway, till next time. Till soon. Alright, back. Anyway, it's just kind of ironic, no comments on the subject. But anyway, so I'm going to move on to the next subject until I can come back to this subject. So we just leave it as a... I still think the basic idea that redshift is being caused by the interaction of photons with material in space as it travels, which basically is a fatigue argument, right? It's not, obviously the light's not getting slower. It's no real fatigue. We're just using the word fatigue to describe the fact that the progress of the light is fatigued, as it interacts with things. But anyway, but that brings up this other stuff, so I'm just going to say spin isn't a made-up concept. Yeah, it's a word used that isn't totally accurate. Just like I just said, it's sort of like light fatigue, when now it's not really. And people are just, we have limited language, so yeah, we have to use these analogies, and we're using analogies where we don't really have anything that's really like it. So you have to go with something that's just close. Anyway, I do know sarcasm, so this is back to the electric boom thing. So all I said in the video was the guy wimped the fuck out, and somehow this guy's saying no, he didn't, and he's going to just say he did. So what the fuck? I do know sarcasm, but QED. Well, I'm just saying QED. All right. In a physics conversation, the first reflex of the brain is to think quantum electrodynamics. You're not really doing the Latin thing then, right? So this is more broken language, right? I mean, the two things just happen to have the same initials. I mean, quantum electrodynamics clearly wasn't called quantum electrodynamics because it comes out to be quo idiom demonstratum in Latin. That wasn't why. Okay, so anyway, I mean, it's like magnetism, right? I mean, it's kind of funny, right? The word comes from magnesia, but the word magnetism, magnifying, has a lot to do with kind of what magnets are doing. They're kind of magnifying a force, so it's kind of an interesting, whatever you call that, coincidence. And that's all these things are, is coincidences. But whatever. So to you, QED is this Latin crap. Okay, to me, that's the last thing my brain is going to figure. Oh, you mean some kind of Latin shit, when I'm having a physics conversation. Now, if somebody said it to me on the street, maybe I might have made that. I'd still probably, just because I'm obsessed with this physics crap, I still would jump to the QED. Oh, yeah, that's the physics thing, right? Anyway. Besides, to me, it is clear that Electric Boom actually understood that it wasn't a real apology video. Well, if he understood that he was basically re-insulted and basically said, I'm sorry you're a flat earth idiot. So he just got told by a professor, I'm sorry you're a flat earth idiot. And his reaction is, oh, everything's great. Yeah, we've resolved everything. I'm sorry. That's pathetic. So maybe it's okay when somebody insults your mama, okay, insults your intelligence, your life's work, all of that. You just take it in the ass and say, fine, thank you very much. But real men don't eat that quiche, asshole. So you're just proving you're you know, flaming pussy. He just wanted to end the discussion. Well, why would he want to end the discussion? He started it because he thought it was a real problem. Why are you telling people there's 2 voltages in one location? It just makes physics sound kind of idiotic. You know, it just kind of ruins the whole idea of having rational physics. It can't be 2 voltages, 2 pressures in the same location. It's not possible to have 2 pressures in the same location, 2 opposite pressures in the same location. Whatever the word you want to use. It can't be black and white and all that. It just can't be. It's just not physics. It's electron proton. It's, you know, you can't do that shit, jackass. And he's making an obvious point that, well, the reason why you think there's 2 voltages in there is because you did the experiment sloppily. You made an obvious error. And he shouldn't point that out. And so he just ended discussion by basically saying, oh, yeah, it's okay, we can agree to disagree. You know, yeah, there's 2 voltages, oh, sure, whatever, yeah. I mean, you don't see how that's just doesn't do physics any good at all? That the very few times these assholes actually challenge each other, if they all wimp out when it's coming, you know, when the rubber's starting to hit the road, we're actually going to have a decision. You know, the boxing match, right? They're both sweating. They're both spent 15 rounds punching each other, and they just say, yeah, let's just agree to disagree. Fuck, yeah. Fuck that. You're an idiot. Douche. Alright. So, spin is not a made-up concept. Well, then why do the professional physics, doctorates in physics, why do they say it is? You know, frankly, I mean, it's not like I'm saying it. They say it, okay? They don't take it literally. They say it's just a replacement word for an idea that there's a property that electrons have that is variable, like a spin. You know, they can spin at a different speed, and they can spin in a different direction. So it's like that, but they don't know what it is because they can't measure it. So they can't say it's spin. They just say it's a property, right? And they're calling it spin. They have a whole field of physics called quantum color chromatics or something. They're not arguing that quantums have colors, idiot. Okay? They're just using the word color to describe, look, there's a difference between them. There's red ones, blue ones, and green ones. Or yellow ones, red ones, and blue ones, or however you want to do it. So, you know, fuck you. What is wrong with you, dude? Oh, well, I actually listen to what people say. I pay attention, like you obviously don't. And I've obviously done a ton more research than you have done, you fucking idiot. Yeah, so fuck you in the ass till dead. You arrogant douche on a like I said, do you want me to play all of the Sean Carroll types and the Degrassi Tyson types saying the words, well, it may not be actually spinning. Want me to do that? Fuck you. Ugh. I mean, the other issue is first, we can't see electrons spinning. The other issue is they think they use concepts like the magnetic moment for the electron. It's not a dipole. It can't have a magnetic moment. It can only have a magnetic moment when it's associated with an atom. So, I mean, to call an electron a dipole when it clearly can't be, I mean, it's a negative charge. There's no positive part of the electron. So, I mean, they do lots of cheats. They're just stupid. Alright. Take it in the balls. Yeah, this guy's, oh yeah, I'll take you seriously. No, I don't think I will. Oh my god, you have serious mental problems, dude. So I've already talked about people who use dude, right? You're the one with a serious cognitive disassociation. To think that, you know, somebody's going to react to being called your dude, okay, with anything but hostility. So you're just kind of stupid to think anybody who has any balls and doesn't take it in the balls will be called dude by a douche like you. All right. The moment you prove yourself the better man, well, then maybe you can call me your dude. Okay. But until then, I'm not your dude. I'm not your pussy. I'm not your vagina. I'm not any of this shit. Okay. Yeah, I know you do it in the ass, so you know. I'm not your anus. Fuck you. But anyway, this whole you have serious mental problems. Yeah, I'm rational on a planet of douchebags who call themselves take it in the balls. Fuck. I mean, fuck. Alright. So, I guess that'll have to do. So, I guess the next subject will be time dilation, and then we'll, move on down the list, and I'll come back to this redshift argument. But at the moment, it's a gray area. Still asserting it's viable, but it's gray. Okay, it's not as black and white as I would have liked it to be. So anyway, till the next time, and such, so forth and whatnot. Irritating. Just irritating. Yeah, I mean, I've sort of demonstrated just how easy it is to do. Well, it looks like. Gotta go a little deeper. Okay, anyway. Just can't jump to a conclusion. You gotta drag it to the conclusion booth, and you gotta go through a whole, there's just no shortcuts to conclusions. So, like I said, see, if regular physics had to go through this process, they wouldn't have made so many fucking mistakes. Frankly, if they would have done their thing publicly, we're going to decide what interpretation of the two-slit makes the least amount of sense. Whether the photons have radar, or whether the new universe is created, or whatever the other one is. If they did that publicly, I don't think they would have chosen any of them. Anyway, until they would have kept saying, no, there's something else happening. Okay, so till next time.